Good evening, everybody. I'll be explaining problem number 26 and next two more self-practice programs from Labsheet 2. Coming to first problem, problem number 26, which is to compute the sum of following series. Look at the series. Series is something like this. 1 to the power of 1 plus 2 square plus 3 cube plus 4 to the power of 4 etc. till n to the power of n. This n you'll have to read it from the keyboard. Suppose if I read n as 2, what will be the output? It is just 1 power 1, which is 1, plus 2 square, which is 4. So 1 plus 4 is 5. So this should be our output. Similarly, if I say n as 3, answer should be 1 plus 2 square plus 3 cube. Okay, it is 1 plus 4 plus 27. Likewise, it depends on the n you read it from the keyboard. Look at the flowchart now before I execute the program. As usual, first you begin the program, begin the flowchart, then declare n. You know why n is required now. I will be using nested for loop to solve this problem. So I require two indices. I've used I and j, and initially some value is 0, and I need product variable to compute the square or cube depends on the n. Okay, next what I'll read here. I'll have to read n. As I told earlier, we'll be using nested for loops. So for the outermost for loop, okay, for the outermost for loop, index value I is equal to 1. I is initialized as 1. Okay, how long you will compute the series? It depends on the n. That is the condition. I should be less than or equal to n. Okay, then if the condition is satisfied, if the condition is true, then you will initialize the value of j, and each time when you get into the innermost for loop j, your product should be initialized as 1. Every time it will be initialized as 1. Okay, then you have a condition here. Your j outermost for loop will run till it reaches I. Okay, suppose for example in the series we have 1 power 1 plus 2 square plus 3 cube. Okay, how long this j will run? For the first for loop till it is less than or equal to 1. Second time till it reaches 2, meaning 1 power 1. Next is 1 into 2 plus 2 into 2. Next, when it is 3, it is 3 into 1 plus 3 into 3 plus 3 into 3 into 3. So it will actually compute the product till it is less than or equal to I. Anyways, we'll trace this program. You need not to worry. Okay, and you will keep on incrementing j value. Okay, if it is true, you will keep on incrementing the j value, and similarly you will compute the product prod into I. That is the variable, or how you compute the square or cube or any power. Okay, okay. One, if the condition is not, if the condition fails, then you will not come out of the outermost for loop. You will just come out of the innermost for loop, and you will compute the sum. Okay, suppose for 1, if I'll just take the simple example here. N is equal to 1. Okay, the product is 1 and j is less than or equal to 1. Condition is satisfied. What is the product here? Product is initialized to 1. So 1 into I value is 1. 1 into 1. Again, when you increment j value, what will happen? J reaches 2. So 2 is not less than or equal to 1. You will come out. And what is the sum now? Sum is initially 0. 0 plus prod. Prod is 1. So sum is equal to 0 plus 1, which is 1. Again, if you try to increment I value here, okay, what will happen? I is 2 now. 2 is less than or equal to 1. Is it true? No. You will come out and print sum, which is nothing but 1. So likewise, as n increases, the product and corresponding sum is computed. Hope you understood nested for loop flowchart. See, first and foremost, you will have to write the innermost for loop, the outermost for loop. Then if this is true, you will get into the innermost for loop j. Then once this condition is satisfied, you will be in looping. If the condition fails, you will come out of the loop. Okay, Similarly, if the condition of the outermost for loop is false, you will come out and print the sum. This is how you write nested for loop. Okay, then coming to program. As I told you in the flowchart, you'll have to use two for loops here. We call this as nested for loop within a for loop. What is required here? You'll have to read n. Before that, you'll have to declare n, and you need two indices for two for loops. Okay, initially sum value is 0 and product is just declared here. Okay, once you read n using printf and scanf, printf is not mandatory here. Just for us to avoid the empty screen, I am writing some message into the value of n. Immediately it will allow you to input n value. Okay, coming to the outermost for loop, which is I. Okay, this is the initial value condition I less than or equal to n, and you will keep on incrementing I value. I'll show you the tracing part. You need not to worry. Then you can generalize it. So that will be easier for you to understand. Okay. Before you get into the J loop, always you'll have to initialize prod variable as 1. Then you will get into the innermost for loop, which is J. J initial value is 1. Remember, your condition is J is less than or equal to I. Okay. J plus plus. Okay. What is it? How do you calculate the product here? It is always product into I. Okay. Then finally, when the condition is failed here, you will come out and print that particular sum. Again, you will continue with the I. I mean the outermost for loop. Even if your outermost for loop condition becomes fail, then you will come outside the outermost for loop and print some value. How is this executed? I'll show you the program. This is the program. Okay, I'm using div C++ 5.11 to execute C programs here. Click here. If I enter n value as 1, I'll get the sum of the series as 1. You know this already. Anyways, we'll trace this. Just know how to execute it. If I compile and execute, and if I give n value as 3, the answer should be 1 plus 2 square plus 3 cube, which is 32. Okay, let us see the execution part now. I mean the tracing part. Suppose if I enter the value of n as 4. Okay, how many iterations you expect? Definitely 4. In the first iteration, what is the I value? I value is initialized as 1 and I should be less than or equal to n. That is our condition. What is I value? 1. 1 is less than or equal to 4. Yes, it is true. Then you will get into the innermost for loop wherein you initialize product value as 1. Then you get into the loop condition and initialization. What is the initialization here? J is equal to 1. And what is that condition we have given here? J less than or equal to I, meaning 1 is less than or equal to 1, which is true because still it is equal. Okay. Now, before I increment J, I will do the next two steps. What is product here? Prod into I. What is prod initial value? 1. What is I value? 1. So 1 into 1 is 1. Okay. Again you will increment J value here. What is J value? 2. 1 J plus plus means J is equal to J plus 1. 1 plus 1, which is 2. 2 is less than or equal to 1. What is I? 1 here? I. Okay. 2 is less than or equal to 1. False. What will happen here? You will come out of the innermost for loop J and you will compute the sum. What is the initial value of sum? 0. 0 plus 1 is, what is the product here? 1. So, sum is sum plus prod, which is 0 plus 1, 1. Okay. Now, the sum value is 1. Now, you have come out of the innermost for loop J. You will now increment the value of I, which is an outermost for loop. What is the next value of I? I plus plus. I is equal to I plus 1. 1 plus 1. 2. 2 is less than or equal to n. What is n here? 4. So yes, it is still less. Now, again you will get into the J loop. Before that, you will initialize product value as 1. What is J value? It is 1 again. 1 is less than or equal to I? 1 is less than or equal to 2? Yes, it is true. Look at the way now. Now we have computed 1 per 1. Now we will be computing 2 square. How it is? Product is equal to product into I. What is product initial value? 1. 1 into what is I value? 2. 1 into 2, which is 2. Again, you will increment j value. J is 1 plus 1, 2. J is less than or equal to I. 2 is less than or equal to 2. Yes, it is true. Now you will compute prod into I. What is prod value? It is 2, which we have computed in the previous thing, which is 2. Now 2 into I. What is I value? 2. 2 into 2, 4. Now, again, if you try to increment j value, j becomes 3. J less than or equal to I? No, it is false. 3 is not less than or equal to 2. You will come out and print some value. What was the previous sum value? 1. Okay. In the previous iteration, sum value was 1. Now it is sum plus prod. What is the prod value we got in this iteration? 4. So 1 plus 4, which is 5. Okay, did you understand how 2 square is computed now and how it is added with the previous one per one value, prod value? Okay, now coming to iteration 3, you have now come out of the innermost for loop j. Now you will go to the outermost for loop I. What is the I value here? 3. Okay, incremented I value 2 plus 1, 3. 3 is less than or equal to n? Yes, 3 is less than or equal to 4. Now you will get into the innermost for loop. Before that, you initialize product value as 1. Okay, prod is 1, j is equal to 1. 1 is less than or equal to I, which is 3. Yes, 1 is less than or equal to 3. Now you compute prod value. Prod into I. Prod is 1. 1 into 3. I value is 3. 1 into 3 is 3. Again you increment j value, which is 2. 2 is less than or equal to I. Yes. Then prod this 3 into I. 3 into 3, 9. Now we have computed 3 square. Definitely you will have one more computation here. What is j value? J value is 3 now. 3 is less than or equal to 3. Still it is true. What is the prod value? Prod into I. Previous prod value is 9 and 9 into I. I value is 3. So 9 into 3, 27. 3 cube you have computed. Again you will try to increment j value, but it becomes condition is not satisfied here. J value is 4. I value is 3. So you will come out of the j for loop. Again, in the next iteration, we'll go to the outermost for loop and increment value of I, which was 3 before. 3 plus 1, now it is 4. Is it less than or n? Less. It is not less, but it is still equal to n. So you can do the next. Execute the next statement. What is the next statement? Product is equal to 1 and j value is 1. 1 is less than or equal to I? Yes, which is 4 now. 1 is less than or equal to 4. Remember here 4 computations you will have to do. 4 to the power 4. Okay. Initial value of prod is 1. Prod into I. What is I value now? 4. 1 into 4 is 4. Next, j value becomes 2. 2 is less than or equal to I? Yes, it is less than or equal to 4. What is the product value here? Product value is prod is equal to 4. Previous value is 4. 4 into I is 4. 4 into 4, 16. Again, you will increment j value, which is 3 now. 3 less than or equal to 4, true. You will compute the product value. Previous product value is 16. I value is 4. Now, final product value becomes 64. Again, you will try to increment 4 and check the condition. 4 is less than or equal to I, which is again 4. It's not less, but still equal. Okay, now product value is 64. Previous value into I, which is 4. 256 is the product value. Again, when you try to increment j value, it becomes 5. 5 is not less than or equal to 4. You will come out of the outermost for loop. Okay, and compute the sum. Every time when you do the innermost for loop, you will come out and compute the sum. Okay, for each term in the series. Previous sum value was 32. Now the product value, sum plus prod. Now the product value is 256. So what is the result? 288. Okay. Sum is 288. Now you will go to the outermost for loop and you will increment the I value 4 plus 1, which is 5. 5 is less than or equal to n. N is 4, so it is false. So final sum is displayed after coming out of the outermost for loop, which is 288. Same thing you will get as the result when you try to execute this program. Enter the value of 4. The sum of the series is 288, which is nothing but 1 power 1 plus 2 square plus 3 cube plus 4 to the power 4. When you add up all these products, you will get the answer as 288. Hope you understood this problem. Okay. Next problem is, these two are self-practice problem. Okay. Problem is to check whether given number is perfect number or not. Okay, what is perfect number then? Don't get confused with the perfect square. Perfect square is different from perfect number. What is perfect number then? It is a positive integer number which is equal to sum of its proper positive divisors. For example, if you take 6, okay, what are the possible divisors of 6? 1, 2, 3. When you add up these three, what is the sum? 1 plus 2 plus 3, which is 6. So which is same as the number 6. So hence perfect number. 6 is a perfect number. Similarly, you can think of 14. What are the proper divisors of positive divisors of 28? It is 1, 2, then 4, 7, and then 14, right? Now 1 plus 4, 1 plus 2, 3, 3 plus 4, 7, 7 plus 7, 14, 14 plus 14 is 28, okay? It's 28, which is equal to the number. When you add up all these proper divisors, you should get back the number. Then that number is considered as a perfect number. Let us understand the flowchart now. Look at this flowchart. As usual, you start, then you need a number to check whether it is perfect or not. So you'll have to declare n, and I need to know the possible divisors. For that I am using for loop. So index I am using as you can use any index, and I need to sum up all these divisors. So I need a variable sum which is initialized with 0. Then read n, and initial value of I is 1. What is the condition? Definitely it is less than n, because we cannot consider that number. So the condition is here I less than n. We cannot say I less than or equal to. So you should say I less than n. Then what is that condition? You keep on dividing that number, okay, sorry, yeah, that number whatever you have read by I. Okay, if you get the modulus as 0, then you will take that number and add it with the previous sum. Okay, then what is the next step? Then you keep on incrementing. This follows the loop. Okay, when this condition is failed, you will come out and check the sum as well as your number. If the sum is equal to your number, then you say that it is a perfect number. Otherwise it's not a perfect number. And finally these two should be connected to stop. Okay, hope you understood the flowchart. Okay, now look at the code. It's easy. See, initially I need a variable to read n. Okay, and it should be an integer, positive integer. Enter the value of n using printf, then scanf. You all know how to read it. Then, as I told you earlier, I will be using for loop. Okay, to compute the sum of positive divisors. Then we need to initialize some value to sum up all these divisors, okay, with 0. Now what is the condition? As I told you earlier, the condition initialization should be I should be initialized with 1, and the condition is I less than n. Then I plus plus, keep on incrementing I value till the condition becomes fail. What is that if condition we have here? We need to keep that I value sorry, I, this n should be divided by I, meaning n is the numerator here, I is the denominator, and whatever the remainder you get should be 0. If it's 0, then you add that number I to the sum so that it becomes a positive divisor. Otherwise, if you do not get the divisor, sorry, remainder as 0, then you will not add that to sum. You will simply increment the I value. Okay, now say if the condition is false, then what will happen? You will come out and check your sum and n value. If both are equal, then you say that entered number is perfect, otherwise it's not a perfect number. Let us try to trace this before I show you the execution. Excuse me. Now I've taken simple one, n as, I've read n as 6. You get the answer as 6 is a perfect number. Let us see how we will get this. Initial value of I is 1. What is the condition? I less than 6. So 1 less than 6. What is the if condition we have given? N modulus I, which is 6 modulus 1. Is it 0? Yes, it is 0. Then if this is true, what you are doing? You are actually adding sum and I. What is sum here? Initial value of sum is 0. And what is I value here? In this particular iteration, I value is 1. So 0 plus 1 is 1. Now the sum value becomes 1. The next step, you will increment I by 1. 1 plus 1, which is 2. 2 less than n? Yes, which is 6. 2 less than 6. What is the condition? N modulus I. 6 modulus 2. Is it 0? Yes. Now the sum is previous sum, which is 1, plus this I, which is 2. So sum becomes 3. 1 plus 2, which is 3. Okay, next I value is 3. 2 plus 1 is 3. 3 less than n, 3 less than 6, yes, true. 6 modulus 3, meaning n modulus I, which is 0. So sum becomes previous 3 plus and this I, which is 3. 3 plus 3 is 6. Okay, again when you increment I value, I becomes 4. 4 less than 6, yes, 4 less than n. Now, condition n modulus I. 6 modulus 4. Is it 0? No, it is not 0. You will not do any manipulation. You will not compute sum here. You will simply increment I value. I is next to I value is 5. 5 less than n, which is 6. Yes, it is still. You will now check out the if condition, which is n modulus I. 5 modulus 2. Is it 0? It is actually not 0. So you will not compute sum. You will simply increment I value. See, if the condition is if condition is not true, you will simply increment I value. Okay. I value, next value is 5 plus 1, which is 6. 6 less than 6? No, it is false. You will come out of the for loop. Okay, now what is the sum value? It is 6. What is your n? Which is 6. Both are equal. Then 6 is a perfect number. Possible divisors of 6 are 1, 2, 3. When you add up these three, 1 plus 2 plus 3, which is 6, which is same as 6, and 6 is a perfect number. You can check out the other number which is not a perfect. Look at this. What is the value of n I have entered? It is 4. 4 is definitely not a perfect number. But how to come to this conclusion? Okay, initially I value is 1. 1 less than n, 1 less than 4, true. 4 modulus 1, meaning n modulus I, which is 0, yes. So sum becomes initial value plus I, sum plus I, 0 plus 1, sum is 1 now. Again, increment I value, which is 2. 2 less than n, 2 less than 4, true. N modulus I, 4 modulus 2 is 0. So sum becomes 1 plus I, which is 1 plus 2. Sum is 3 now. Increment I value. I is 3. 3 less than 4? Yes, it is true. N modulus I, 4 modulus 3 is not 0. Okay, you will not compute sum. You will simply increment I value in the next step. I value is 4. 4 less than 4? No, it's false. You will come out of the loop. What is the sum value we got? it is 3. And what is the n value? 4. 3 is 3 equal to 4? No. Hence you can say that 4 is not a perfect number. I'll show you the execution. See, I shall give value of n as 28. I told you 28 is a perfect number because 1 plus 2 plus 4 plus 7 plus 14 is equal to 28, which is same as the number. I'll give one more example. I say 13. 13 is not a perfect number. Okay. Hope you understood this problem. Next question in the self-practice is write a C program to count the total number of digits of an integer number n. This is also very simple. It's very simple. See, for example, I've read number as 2, 3, 4, 5. How many digits are there? 2, 3, 4, 5. There are 4 digits totally. So what you need to do is you'll have to extract each and every digit, okay, and add up the number of digits there. Okay, it's very simple. I'll show you. Before that, let me explain your flowchart. See, as usual, you start, then you declare n value. Definitely, you'll have to read a number. Okay, then just for printf statement, I require one more variable r. Otherwise, this r is not really required. Then I need count. Count is very much required. I need to count the number of digits in this particular number, and count initial value is 0. Okay, let me now save the original number in the r, variable r. I'll tell you why it is required. Okay, now what is the condition I need here? Oh, I think this you have done in extracting number, that odd number registration, even number registration in that program. You might have used this concept or logic. Okay, what is the condition? N should be greater than 0, meaning n is not equal to 0. Okay, if this is true, you will divide that number by 10. Okay, and what will happen when you divide it? Every time you will, from the, what do you call, LSB, one digit gets reduced. This is the idea. Say if it is 2, 3, 4, 5, in the next iteration it will become 2, 3, 4. In the next iteration 2, 3. In the next iteration 2. Likewise, you will extract each and every place digit there and count the number of digits. This is the idea. Okay, next, if this is the case, you will increment the count value by 1. So you keep on doing this until the condition is satisfied. Once the n becomes 0, you will come out and print the number which has so many count digits. Did you understand why I require r here? R is to hold the original number. So finally I can print and say that r is having so many digits. That is the idea. Then finally you terminate it. Don't worry, I'll explain you the code and tracing part. See, I require here 3 variables, n, r, count. And what you are reading here, you are reading n value. Okay, and you will assign this n to r just to save the original number. Now, n, what is the condition? N is greater than 0. I'm using while loop here, and if this condition is satisfied, then I'll divide that number by 10. After dividing that number by 10, I will store the quotient in n. Okay, then I will increment count by 1. Initial value of count is 0, then I will increment count by 1. So I'll be repetitively doing this. I will keep on dividing that number by 10 and storing the quotient as n and updating the count. This will happen till n becomes 0. Once n becomes 0, you will come out and print this message. See here, I'm printing like this. The number percentile d as percentile d digits, meaning r, the number, original number r. That is the reason why we have stored the number to, where we have assigned number to r. See here, here n becomes 0 at the end of the iteration. So to save the original, we are using one more variable. the number has so many digits. Meaning, suppose if I give 2356, the number 2356 has 4 digits. So how many format specifiers you have used here? 2. So how many variables after comma? You expect 2 variables. You remember like this, you'll not forget. Okay. See, for the tracing, I have taken this example, which is quite easy. See, enter the value of n. I've entered 4-digit number. You all know that I should get the count value as 4 at the end. Now I'm storing this original in variable r just for the printing sake. It is really not required. Okay, what is the condition? Condition says n should be greater than 0. Definitely in the first iteration 4, 5, 6, 7 is greater than 0. If this is the case, then I will divide this number by 10. See, your 7 is gone now. What you are left with? You are left with, the quotient is 4, 5, 6 now. Okay, it is the LSB. Okay. Now, initial value of count is 0. Now it becomes 0 plus 1 because the condition is still satisfied. We are simply incrementing count by 1. Count is 1. Okay, in the next case, what is the n value? N is 4, 5, 6 now. 4, 5, 6 is greater than 0? Yes. Then you divide that by 10. 4, 5, 6 by 10 is 45. 6 is gone now. Now the quotient is only 45. Again increment count by 1. Initial value is 1 plus 1 is 2. Okay. 45 is greater than 0? Yes, still it is 0. 45 by 10. What is the answer? 5 is gone now. Now you have only 4. Count is 2 plus 1, which is 3, incremented by 1. Now what is the n value? N value is 4. 4 is greater than 0? Yes, still it is greater than 0. 4 by 10. Now 4 is also gone. You are left with 0. 0 point something. Since we have declared this as an integer, you will get only the integral part, which is 0. Count is now 3 plus 1, 4. Okay. Now what is the condition? N should be greater than 0. What is n value now? 0. Okay. So the condition fails. You will come out of the loop. That's why you are printing your number 4, 5, 6, 7 as how many digits? 4 digits. This is R because we have saved the original number in R, and this 4 is nothing but count. This is the result you get at the end. Okay, I'll show you the execution. I shall enter 6, 7, 8, 4, 5. So how many digits? Oh, so sorry, I executed the previous one. The number 5633 has 5 digits. Okay. Just a second. Okay. If I give the number 678885 adds 7 digits. Okay, hope you understood. Thank you.